Our company TOPODRONE, we produce equipment for precise survey and mapping. We design and produce high precision GNSS receivers to be installed on the drone, and we produce special equipment and special upgrade kits which can be installed on any DJI drone right now in order to convert this drone to a professional survey machine. Our company was established a few years ago when we created upgrade kit for Phantom 4 Pro, and it was created a few years ago before DJI RTK Phantom was introduced by DJI company. And we use this equipment, we use our own solution for Phantom 4 Pro for precise survey and mapping for our own purposes. And after that, we found out that this equipment is very popular, and it can be used in any application which needs to get precise measurement and to get precise three-dimensional model and photogrammetry models. And as a result, we decided to share our experience, to share our solution for surveyors. And right now we upgrade drones with two frequency multi-channel survey grade GNSS receivers. It is based on u-blox chipset, and we created it by our company. And after that we install it on the drone, and as a result you will get very precise measurement of the position of the drone and very precise measurement of each photo. Our solution works in post-processing kinematic techniques. It looks like real-time kinematic techniques. It means RTK, and our solution works in PPK. But PPK and post-processing kinematic techniques is more accurate and is more stable in comparison with RTK. Why? When you fly with RTK, you need to provide real-time correction information which should be sent from the base station to the drone, and after that drone GNSS receiver installed on the drone can measure precise position of the drone or precise position of the image. With our solution you don't need to create real-time connection between real-time link between drone and the base station. You just fly with our solution, with our equipment on board, and after that you download data from base station, you download data from the drone and post-process data like it looks like RTK but not in real time, but as a result you will get more precise results as soon as you process it in post-processing. And you can add special filters such as SNR mask, such as elevation mask, or you may switch off some satellite system, and as a result you will achieve better accuracy, and you can fly easily within 20 or 30 kilometers range from the base station. As the base station you can use any GNSS receiver which stores RINEX data with 1 GHz rate. So it doesn't matter which GNSS receiver you use as a base station, or you may just download RINEX file from a coarse network or a trip network which is available in your country. Today our users show how to use our equipment, how to connect to another one network to download RINEX file and don't use your own base station. So, and today I will show how to post-process data. And inside of our equipment, we supply software for GNSS data post-processing as well. So, as I already said, we started from upgrading Phantom 4 Pro, but now we create a wide range solution for DJI drones. I think the most popular drone right now, surveying drone right now, it's a Mavic 2 Pro, which is upgraded by our company. It has very good high resolution Hasselblad camera, and it provides accuracy like Phantom 4 Pro, but with removing of rolling shutter distortion, which can be done in Pix4D software, for example. Mavic 2 Pro, it is a very small and very useful drone, and it's a really affordable tool for surveying mapping. It's very good. Then you can take this drone in your hand and just store in a pocket and in your backpack, and you don't need to carry big boxes. So, but it provides very, very good accuracy. And we have 2-frequency GNSS receiver inside, and it works in PPK mode like a Phantom 4 Pro, but much lighter. And I think in some cases Mavic is more stable in comparison of Phantom 4 Pro. For example, if we are talking about the quality of the plastic parts, you know that Phantom 4 Pro sometimes has some scratches close to the motors, but Mavic 2 Pro is much better, has much better quality for plastic parts and for the body. And we provide ready-to-flight systems like ready-to-fly drone, or we can provide upgrade kit for Mavic 2 Pro. And with upgrade kits, and I would like to announce that we change our prices right now, and all our equipment becomes cheaper. An upgrade kit for Mavic 2 Pro as well as for Phantom 4 Pro costs less than 2,000. So you just install a small part, and this installation is very simple, and you convert your drone to a really precise machine, and I will show later how to process data and what kind of accuracy we achieve. So everything will be shown here today during presentation. Next, our product, it's as I already said, it's a ready-to-fly system Phantom 4 Pro. The price is for ready-to-fly system for Phantom 4 Pro PPK is less than $4,000, and upgrade kits costs less than 2,000, as I already said. Next, our solution, we provide solution for PPK survey, for high precision survey, in order to install on Matrice 200 or on Inspire V2. And you can install our upgrade kit, which includes camera and GNSS receiver, and you can fly easily within a very wide range, up to 20 kilometers from a base station. And Matrice 200, I think it's the best enterprise solution. It's the best stable drone right now at the market, and it can fly in any wind conditions. For example, it can. We already tested that it can fly with a speed more than 20 meters per second. And it has a waterproof body, and it has very good motors, which is waterproofed and sand-proofed. And you can easily upgrade Matrice 200 or Matrice 210 version 2 or version 1 with our solution. And we have wide range of upgrade kits for Matrice 200. We can install 20 megapixel camera, X4S camera, which is upgraded by our company to get precise coordinates of the images. Or we can install Sony cameras. For example, we can install Sony RX2 or R7 IV cameras with a resolution from 42 megapixel to 61 megapixels. And it's very good decision to install such high accurate and professional cameras on the drone, and I think it will be very popular for surveyors, because right now there is no any solution to install such high resolution camera on Matrice 200. There is just only one way to install X7 camera or Sony right now. And Sony is connected to our Sony camera is connected to our GNSS receiver, and it has 3-axis gimbal, so you will achieve very good results. And I will show later how to process data from Sony cameras as well. And of course, we create solution for multispectral survey. We can install multispectral cameras on Phantom for Mavic, for Phantom Pro, or for Matrice, and we can install wide range cameras, and we can connect it to GNSS receiver, and as a result you will get very precise multispectral mosaics. And I think one of our users will show how to process multispectral data and how to achieve very high precision results. And right now I would like to announce our new product. First of all, it's DJI Mavic Mini with PPK installed on the drone, and it looks like a toy, but in reality it's a very good survey drone. If you need to survey small areas such as 10 hectares or 15 hectares, you can easily survey with this drone. This drone has very good camera. It has there is no autofocus in the camera, so focus of the camera is stable, and as a result you will achieve very high accuracy in altitude as well. We already tested this solution and I will show you some results, but with Mavic Mini you can achieve easily accuracy within 3 centimeters X, Y, and Z. And as you know, Mavic Mini, it's a lightweight drone, and in some countries you can use this drone without any restrictions. You don't need to get approval to fly with this drone. So it will be very good solution for surveyors. If you need to survey small areas, you just take this small drone, and after that easily survey. And I will show data processing from this drone as well. And of course we have solution for to install high precision cameras, which I already said you that we can install on Matrice 200 high resolution cameras, 42 megapixels and 61 megapixel cameras, as I already told you. And we can provide upgrade kit, and we can provide ready to fly system, and it's our new product, and I think it will be very popular in the future. From our experience, we know that for surveying we need additional equipment to make survey from the ground, and today I will show how to use this equipment. But this combination of aerial survey and ground survey, you will achieve very high accurate models of buildings or cities, and for this purpose we specially design survey kit which can be installed on a 3-axis gimbal and can be mounted on the car, or you can take it in a hand. And after that you may survey with you make simple photo surveying, but we measure precise position of the photo, and after that it will be combined with aerial survey as well. And finally we are going to introduce our new solution. It's I think it will change the market of high precision LIDAR survey. We just created and designed a very lightweight LIDAR, which is based on Velodyne LIDAR, and it can be installed as well on Matrice 200, or it can be installed on Matrice 600. The weight of the LIDAR is less than 1 kilo, and it has very precise IMU inside and GNSS receiver. And it is combined in one system, and as a result you will make very high precision survey and high detailed point cloud, as well as in the forest areas or in the grass areas, and you can survey vegetation areas which are covered by vegetation without any problems with using our LiDAR. And our LiDAR is compatible with our solution, for example X4S cameras, or we can install additional camera to the LiDAR. As I already said, LiDAR can be installed on Matrice 200, and the flight time mission can be 22-23 minutes, and you can easily survey 100 hectares per flight, and you will achieve very high accurate and detailed models with possibility to walk in the vegetation areas. And of course, you can fly against strong wind, and you can fly in any weather condition because it is installed on a very high professional drone. We tried to create affordable LiDAR, and we announce our prices, and the price for the LiDAR for ready to install on the drone, including 2-frequency GNSS receiver, including very precise Honeywell IMU, is less than $20,000. And right now I will show you some examples of LiDAR data processing. So as I already said, we have inside precise IMU combined with GNSS receiver, and after post-processing together IMU GNSS receiver data, we will get very precise trajectory of the flight, including all inclination of the drone. And with using this information, we can process point cloud very precisely. And this one is an example of LiDAR data processing. It's our flight. We made 6 lines of survey. After that, we combine it together. And as a result, we got detailed point clouds, and there is no noises in point clouds, and you can see that we can measure level of the terrain under the trees as well. And this one example of the three-dimensional model of forest area, which was surveyed by our solution, and you can see that we can easily measure ground under the trees, and we can easily measure altitude of the trees, everything you need. And if you want, I can show you point clouds in more details. This one is point cloud. This one is an example of point cloud combined with trajectory of the flight. And here we can look at the levels, and we can look at the quality of the point cloud as well. This one is an example of slice of the point cloud, and we can make slices over the trees or buildings as well. And you can see that we can trace terrain level, we can trace buildings, everything you need. And this one example of real point cloud over the forest area, and we can measure altitude of the trees as well, and we can measure terrain level under the trees. I think this one solution, this equipment will help to survey in a forest area or high vegetation area. And it can be combined with X4S camera as well. So I will show the real setup right now. As you can see, we install LIDAR on Matrice 200, and it can be easily installed and removed. And it can be combined together with X4S camera. It can be combined together with X4S camera. It receives power from the drone. And it is really easy to install and easy to survey. And as I already said, the weight of the LiDAR is less than 1 kilo. As a result, you can fly more than 20 minutes with Matrice 200. I think it will be 24 minutes. And you can fly with high speed, with less overlapping. As a result, you will easily cover huge areas. And you don't need to process photogrammetry data. You need just to create point cloud and then use data from RGB camera to create real color point cloud. Taking the chance, I would like to show all other our products. You can see that we have Mavic 2 Pro, which can be installed with, which can be combined with multispectral data, with multispectral camera, and it's very easy and very affordable multispectral, high precision multispectral solution. We are going to show you our new drone. It's Mavic Mini. It's the smallest drone right now. It's the smallest survey drone on the market, and you see that you can easily put this drone in your pocket, and it flies with our equipment. It can fly approximately 16 minutes, and within 60 minutes you can easily survey 10 or 12 hectares of territory of your area. And I will show you some examples of data set which was derived from Mavic. This one model was created from data set which was captured by Mavic Mini with installed upgrade kit on the board, and the quality of the data is very high, and the precision of this data is approximately 2 or 3 centimeters. And we measure some ground control points, and we check the accuracy in the field as well. And this one model was created in order to create a topographic map, to create a map chart for further reconstruction of the building. And this one example of another one survey of the small area. And as you can see, the quality of the model and the details of the model is high. And I think this drone will be very popular as soon as it is very cost effective and provides very high quality data as well. We have few minutes to answer your questions if you have.
You mentioned that the upgrade kits can be done by ourselves, so there is no need to modify the camera, right?
Yes, right now we create solution which allows to install upgrade kit by yourself, and you don't need to modify the camera. And I would like to show how with upgrade kits it looks like. It's a box, Inside of the box there is a flexible cable, 2-frequency GNSS receiver, which is easily installed on the drone, and you don't need to make any holes in the drone and so on, and helix antenna, and nothing else. So in order to install the kit, it will take you just 5 or 10 minutes. And we have the same upgrade kit right now for Phantom 4 Pro as well. And as I already said, that it is easy to install, and it is it has very cheap price right now.
Have you tested the F9P in RTK mode, not PPK?
Yes, we already tested F9P in RTK mode, and we have such solution, but we decided that it is not useful for the drone. Why? Because you need to provide a direct link to, you need to provide direct connection between a base station and the drone. In this case, you need to install GSM modem or radio modem on the drone. And with RTK survey, you will fly with less speed. For example, real DJI Phantom 4 RTK during surveying in RTK mode can fly with a speed from 3 to 5 meters per second. It's like a people walking in the field. But with PPK solution, from the same altitude, you can make survey with a speed up to 10 meters per second. So your efficiency is much better with PPK solution. And for data processing, PPK solution is more accurate. As soon as you can implement additional correction and you can process data set, you can implement special filters and special techniques to increase accuracy. During real RTK survey, it's not possible. And right now, as soon as we launch our software for RTK, for post-processing of data set from Phantom 4 RTK, it's very popular, and a lot of people start to use survey drone very efficiently. And later I will show our software as well and how it works. Okay, I will continue my presentation, and now we are going to discuss a little bit about our software for GNSS data post-processing. And after that, I will show you some data processing workflow. And I will show you data processing workflow on the example of 42 megapixel Sony camera installed on Matrice 200. Okay, now we are going to talk about our software, TOPOSetter. TOPOSetter software, it was firstly created just to make a link between images and precise coordinates. And we use post-processing in other softwares. The main disadvantage of this workflow that we couldn't process data in a custom projection, for example, or we can use expensive software for post-processing data in a special projection or custom coordinate system. Right now, we created our own software for GNSS data post-processing and images geotagging, which supports all kind of projections, and it supports any ellipsoids and datums, and it has a lot of capabilities to improve efficiency of data processing. For example, you may post-process multiple flights from one base station. For example, you fly all day and you make 10 flights per day or more flights per day, and our software provides possibility to process all these data sets automatically, and you don't need to choose and click and to spend a lot of time to process your data. Just set up data processing workflow, and our software processes it automatically. Another question is when you use common DJI drones, usually all images are stored with the names starting from 1 to 1000. After that, it creates new names. And in this case, if you process data together in one chunk, but with the names from 1 to 1000, and then name starts again 1 to 1000, it will lead to some error or some misleading information. And our software rename images automatically. Additionally, we apply some correction due to the drone angle flying to the position of antenna. We can add some offset of the antenna. So we have a lot of we have a lot of efficient tools which is very vital for surveyors. Why we created? Because usually we make survey by ourselves, and we know what surveys are needed. And of course, we receive a lot of questions about, do you support DJI post-processing of DJI RTK? And right now we create software for post-processing GNSS data for to enable PPK processing for DJI RTK system. And it has the same capabilities like our original TOPODRONE software, but it supports DJI RTK, and you can easily process multiple flights. You can improve post-processing. You may add some filters for GNSS data post-processing, and I will show you it later. And one of our users will show some examples of data processing with this software as well. And usually, and what kind of software we would prefer? We prefer for photogrammetry processing. Of course, Pix4D. Why? Because Pix4D provides the better, very detailed point clouds, and I think it's very high. It provides very high quality of point clouds, and additionally, it has correction of rolling shutter inside. So if you use camera with rolling shutter, for example, like it was installed on Mavic 2 Pro or on Mavic Mini, you may use Pix4D to correct rolling shutter. And as a result, you will have very precise data processing. And if you have some question about rolling shutter correction and rolling shutter distortion, you can visit our blog, and in our blog we have special article which describes the technology of GNSS data, of photogrammetry processing of from rolling shutter. And for mission planning, there were a lot of questions about mission planning. For common application and for common survey, we use, of course, simple software like Ground Station Pro, DJI Pilot. But if you need to make special flight mission or oblique flights or some flights in the mountains, I would suggest to use UGCS. And UGCS, it's a perfect software for mission planning, especially if you are working in the field where there is no any internet connection, and you may create mission planning without any connection to the internet, and we will describe it later as well. Okay, so now, and what I would like to add more, that we have now we launch a system which provides connection for our clients who already bought drones. We have a special online system to receive orders for survey. For example, any customer who is interested in surveying can just draw the area on the map and can send a request to make survey, and always requests are redirected to our users who use our drones. So as a result, client will have very high precision model and very high precision quality dataset derived from our equipment, and our clients will have orders, and it will help them to work in strong market conditions. And there were a lot of questions where our equipment are used, and our equipment is used in a lot of countries, and I just show you some. And today, some of our friends and clients will show the using of equipment in Antarctica, for example, in Slovenia, in Croatia, in Israel, in Switzerland, and we have clients in Poland, and we have clients in Middle East area. We have a lot of clients in Middle East area, and our clients work in Costa Rica, in Australia, in Finland, in Spain, in a lot of countries in Europe, and of course we have clients from Australia. And this one example, it's a TOPODRONE client. We met him in Cambodia, but he is from New Zealand now. He is living in Australia, and he is very professional. If you need, we will provide you contacts. And of course, we work with the mining companies and in Finland and Philippines, and we worked with Indian company, and you see how many drones are used in for forest monitoring in Finland as well. But now let me show data processing workflow. So our data processing workflow is very simple. First of all, let's talk about Matrice 200 with Sony RX1 camera with 42 megapixel camera. First of all, we just create mission planning, and mission planning can be done with DJI Pilot or in UGCS software. It doesn't matter, but UGCS, as I already said, provides better quality, and UGCS provides possibility to create very precise flight mission. And after that, you can just export this mission to KML format and just upload it to DJI Pilot, for example, through SD card. And after that, as soon as we create mission, we perform survey mission with from altitude of 300 meters, and from 300 meters we covered more than 100 hectares per flight, and the flight lasts more than 20 minutes with the Sony camera, and the flight speed was 15 meters per second. And Matrice 200 is a perfect drone, and with installation of Sony camera, we create very good survey machine. And here it's example of our survey, and here you can look at the screenshot about batteries after 20 minutes flight, and about flight mission, which it's a real screenshot captured from a real application. After flight, we need to download images from SD card from the drone. We should download UBX file from the drone. It's stored in SD card of in our upgrade kit. And after that, we should download information from the base station. As a base station, you can use any GNSS receiver. Or you may download data from any Corso and Trip network. It is available. And here, as example, we download information from the base station, from a course network, which is situated within a 16 kilometers range from our flight area. And we just download it, and when we input it to the software read the position of the coordinates of the base station, precise coordinates of the base station, which is stored inside of a RINEX file. It's read the altitude of antenna, and what we need to add, the offset of the antenna above the camera. After that, we should choose processing options. Should we use data conversion, GNSS data post-processing, or image matching? And of course, we should choose a coordinate system. Right now, we support any coordinate system, and if you need, you can import a coordinate system from PNG file. For example, you can export it from any software and then import it to our post-processing software. And what else? And our software read the RINEX files as well. And you can look at software interface, and you can understand the timing of RINEX data. You can understand if RINEX data from a drone and RINEX data from a base station is overlapped, which is very important for data processing. And of course, we support batch processing. So you just create a project, just add the data from another one flights for the same base station. And after that, just click process, and all data processing will be made automatically. As a result, you will process all data set, for example, 10 flights or more, without any problems if you use one base station. And of course, when you download RINEX from a network, usually RINEX files are cut for the length of 1 hour. In our software, it's possible to combine different RINEX files to one file, and just to create one long RINEX file. And we have additional settings for GNSS data post-processing. You should choose satellite system. You should choose elevation mask. You can choose frequency. And there are some special options. For example, you can match images automatically in manual mode, and you can assign coordinates inside of EXIF formats, or you can create a text file with precise coordinates and more. And we add a special technology to PPP data processing. So if you have a base station and you don't know precise coordinates of the base station, you can post-process data in PPP mode, precise point position mode, and you will define precise position of the base station with accuracy approximately of 10 centimeters. It's very important when you fly or walk in an unreachable area where there is no any network, there is no any benchmark, and so on. So as I already said, after GNSS data post-processing, we receive accurate coordinates of the images inside of EXIF text, and we receive text file to be imported to Pixel.d, Agisoft, or Bentley software. After that, we just import precise images, precise coordinates of the images to the software, for example, to Pixel.d. And after that, we add checkpoints to check accuracy. After that, we create air triangulation totally automatically. And after that, without using ground control points. And after that, we check accuracy just with using of ground control points. And this is example of data processing of photos which were captured from 300 meters altitude flight. And the accuracy of this dataset was approximately 5 or 4 centimeters. And if you want, I will show later the project.
And the quality of the point clouds, which was derived from 300 meters altitude, is very high, and it is very detailed. As you can see, you can recognize electricity poles, hedges, walls, buildings, trees, everything you need. And of course, with using of automatic classification, you will remove all these objects from a digital elevation model, and you will create digital terrain model. And this is an example how we classify data set, and this classification was made automatically, and you see that all walls and electricity poles or buildings was classified automatically. And as a result, you will create orthophoto, which can be combined with any information, for example, cadastral borders or something like that. And of course, you will create control lines and so on. And this one is an example of our data processing. Now we are going to show you how to use TOPODRONE equipment to make a survey over the mining sites or over the construction sites. And I would like to show a real project which we made in mining sites, in the mining site. And let's start to share my screen, and I will show you. Okay, so first of all, I would like to describe the area where we work. We work in a mining site with in a mountain area, and the altitude of the area was more than 1 kilometer above the sea, and it was very far. This area was situated far from any city, approximately 700 kilometers from any city, and there is no internet and there is no any mobile network, so we couldn't use simple software for mission planning, and we couldn't use RTK system for mapping because we don't have. We don't have any connection to the network, and as a result, we decided to use our equipment, TOPODRONE Mavic 2 Pro PPK, together with MLEAD base station, and we fly. We need to prepare a flight mission, but this mining site is always under changes due to the human activity, and the relief of this area is changing a lot in comparison with the relief data set from Google. And as a result, we need to prepare a flight mission on the on the basis of up-to-date terrain. For this purpose, we decided to make a survey over the preliminary survey to create preliminary three-dimensional model of this area, and after that to create very precise mission. Very precise flight mission on the basis of preliminary create terrain. For this purpose, we use UGCS, and we make first of all simple terrain survey, create terrain, import to UGCS, and then we create precise mission. After that, we perform flight with the Mavic 2 Pro, and this area was approximately 2 square kilometers. And we made survey. We make field walks for 1 day, just for 1 day. We made survey with the Mavic 2 Pro, approximately seven flights. It means that we survey 30 hectares per flight. And we fly with altitude of 100 meters. And after that, we post-process data and import this dataset to the Pix4D software. And we import as well as the precise coordinates of the images, and we import original DJI images together with the precise coordinates calculated by our software. After that, we make automatic air triangulation, and we don't use any ground. So we don't measure a lot of ground control points. We just use a geodetic network which was established in this area by mining company, and we just use this geodetic network to check the accuracy of our survey. So we don't use any ground control points for air triangulation. We use ground control points to check the accuracy. And here there is a result of accuracy checking and in comparison to ground control points. And after that, after creating air triangulation, we create three-dimensional maps and a three-dimensional point cloud. Now I am loading the project in Pix4D. And but to tell the truth, we received very precise, a very detailed point cloud. And in the point cloud, we have buildings, poles, trees, bushes, terrain structure. And it was automatically classified by Pix4D software. Of course, we add some manual classification, but it took us just a few hours to make classification of such difficult terrain. So we remove all trees, we remove all buildings. And the point cloud was very, very detailed. And you can see that from 100 meters altitude, we can measure electricity poles, we can look at buildings, and all objects, as well as barriers and power lines was detected. And they were classified as well automatically, but of course with manual checking. After that, we remove all these objects, and after that, we classify forest area. And here is an example of forest area with power lines. And we make automatic classification of power lines, power poles, and trees as well. We create terrain model and digital terrain model, and we create control lines, everything we need. And as I already said, the quality of the point clouds and the accuracy of point clouds allow us not to measure anything in the field. So we make all vectorization or all necessary steps to create map in our office, not in the field. So we just spend 1 or 2 days in the field to make an aerial survey, to prepare for aerial survey for 2 square kilometers. And it was performed by just 1 or 2 persons. After that, so we spend 10 times less time in the field. And after that, we go to the office and process data. And this one is an example of a data set. In the office, we create contour lines, we create structure lines of the terrain. And as you can see, the details of the point clouds allows us to create a digital map or to make drawing without any measurement in the field. And it's the main advantage of our technology. So we don't need to go to the field to measure points, ground control points, and so on. And we have very strict accuracy. And after that, we can create very precise digital elevation model or vector objects, not in the field, but in the office. And this one example of the terrain created by software, and this one example of the map which was created in the office. And it was compared with archival survey dataset, and it was accepted by the client, and we got approval. And now I would like to show you real point cloud. Okay, and as soon as we load the project in Pix4D, it is a huge project, and as soon as we are loading it, I will answer your question as soon as we have a lot of questions.
Can the new software, TOPODRONE Pro P4 RTK, works with Phantom multispectral RTK?
I think, to tell the truth, we didn't test it, but I think yes, so we can create any support for Phantom RTK or multispectral.
Can TOPODRONE support multi-base option?
Right now, we don't support multi-base option, but we can use one base. But we are thinking to add this capability in the future.
What program do you use to do the corridor planning?
For corridor planning, we use UGCS or MapPilot.
For 3D model, camera angle must be always 90 degrees.
No, it depends on the task. I think we have another type of presentation, and maybe I will show you later how to create accurate three-dimensional models and how to combine different type of oblique survey and nadir survey together and ground survey together.
Why do you use Pix4D software and not your own software?
I think the main idea that Pix4D already created a perfect software, and the quality of the point clouds is too high. And if we spend the time and money for creating our own software, it's not efficient. It's better to use partner software as well.
How do you process the Mavic Air photos in Pix4D?
It's very simple, and I can open later. I can, if you are interested in, I can open the project, and it's totally the same workflow like I show you when we process Sony camera from Matrice 200.
That's all question for now.
Okay, so it's. Yes, okay. Now we will share the screen. And now we will share the screen, and we will show some point cloud, and we will show ground, and we will show the whole project. And now you can see the quality of. So this one, it's a real Pix4D project, and as you can see, we surveyed 2 square kilometers with 1, 2, 3, 4, 5, 6, 7 flights, and some of the images was not aligned due to the that we made survey over the lake, and it is not possible to make air triangulation under the water. But all other cameras was aligned perfectly, and the green color show that the coordinates of the images is totally the same like we provide to the software after GNSS data post-processing. It shows us that the quality of the coordinates, which was calculated by TOPODRONE software, is very good. And as I already said, we don't use any ground control points for air triangulation. We just use precise coordinates of the images derived from TOPODRONE. And now we are loading point cloud, and we can answer some questions. And there was one question about reselling of TOPODRONE products. Yes, we are open to have resellers, and we have resellers in different countries such as Spain, Croatia, Malaysia, Australia. We have all resellers are shown on our website, and we have resellers in Israel, in Europe, everywhere. But and you can contact them directly if you need to get the support or training in your country. And now we load point cloud, and we just switched off cameras, and now we can look at point cloud quality. And as I already said, the accuracy of this point clouds is preliminary 3 or 5 centimeters. And if you want, we can check it by measuring points or something like that. It's already done by the customer. And as soon as we have very detailed and precise point cloud, we can make all measurements and vectorization in the field. And this one example, how we remove trees and other objects from the terrain, this one. And here it's example of vectorization. I think Pix4D has very good capabilities to vectorize objects and structure lines, and it was vectorized manually. And after that, we export it to CAD and create such maps, and we create maps. So it's a short description how we work usually. So we try to simplify our fieldworks, and we try to use software for automatic classification and for automatic vectorization. If you have any questions, I can answer.
Yeah, it's a question about Mavic Mini.
Okay.
Are we playing? Will we support mission planning for Mavic Mini in our own application?
I think we are thinking about supporting mission planning and for Mavic Mini, and I think I think within 1 or 2 months, DJI publish SDK for Mavic Mini. In this case, everybody can create mission planning for Mavic Mini. If you want, I can open a project from Mavic Mini and to show you how to create digital maps from Mavic Mini. And I think right now I like 2 drones. It's my favorite drone, Mavic Mini, because you may take it in any place and with your in your pocket, in your hand luggage, anywhere. You don't need to receive permission for flights. And another my favorite drone is Matrice 200 because it can fly in any weather condition against strong wind and against rain and in any area. But I would like to show you data processing in Pix4D, for example, for Mavic Mini, and I would like to show you some models which was created in Mavic Mini by Mavic Mini as well. So just wait. Вот это открыто, у меня сейчас что показать. О, супер. Yes, this one, it's a flight in a manual mode, so you can fly it easily how you want. Just make one oblique flight and make a grid or double grid mission. And after that, you will create a very detailed point cloud. And as soon as Mavic Mini supports, as soon as Mavic Mini is supported in Pix4D software and in Bentley software and in Agisoft, the camera of Mavic Mini, you will create very precise point clouds. It doesn't matter in any software. And of course, you may, after creating a point cloud, you can vectorize your object and you will create your digital map from a Mavic Mini dataset, like this one. It's a real Mavic Mini dataset, and you don't need to do some special work for data processing. And you see how it is accurate. And we measure the size of the house, and we compare it with information from a cadastral, and the accuracy was 2 centimeters. So it's very, very accurate. And you can measure Mavic Mini data very precisely, like this one. I just show you how we measure position of the walls of the house. We just use images to correct the position. We just first of all create preliminary vectorization, and after that we correct the position of the house with using this tool. And as a result, we got accuracy approximately of 2 centimeters in the size of the building, and as well as in the position of the building as well. So I think Mavic Mini is a future for survey, as well as Mavic Air 2. Okay, and after vectorization, we can export data to AutoCAD, and we can create AutoCAD map easily, like this one. So we vectorize all objects here in Pix4D, and after that we export data to AutoCAD and create map for future reconstruction. And of course, automatic classification of point clouds, it's perfect tool. And now we look at automatic classification of the point cloud, and I think Pix4D is everything you need to process data and to create maps. And this one, just wait while we upload the data in AutoCAD, and I will show you the real result of this dataset. Yes, and this one, it's a small area which was surveyed by Mavic Mini, and we create a map from Mavic Mini dataset, and it is accurate, and we check with GNSS data as well. So I think it's a perfect survey tool for small areas, and in areas where you couldn't fly with the big drones as well. Okay, thank you for your attention. Now